And Kathleen, you'll be able to see how many people are in, so you might just give it 30 seconds before you get started.
Will do. Hello, everyone, and welcome to our very first I2SL Circular Economy for Labs Community of Practice Forum. That's on revisiting expanded polystyrene or EPS foam in labs. And today on our agenda, we're going to go into a little bit about what our community of practice is. Kelly, if you can advance the next slide. What our objectives for this call are, and some of the ground rules for participating in this call, which is a meeting, not a webinar, because we do want to have some participation. We're going to revisit a technical bulletin that the International Institute for Sustainable Laboratories, or I2SL, created a few years ago on EPS and labs, and sort of where we've come since then, including a couple of our suppliers who agreed to speak today on how they work to reduce EPS foam and replace it with other types of shipping products, or get rid of it where they don't need it, from cell signaling technology and Millipore Sigma. We'll have time. I'm going to lead a quick panel discussion with the speakers, and have a little Q&A. Anyone wants to put some questions in the chat, and then we're going to open up the whole panel discussion to an audience participation panel as well. If you have questions, you can put them ahead of time, but we'll also talk about, if there's specific topics or challenges that you're having with EPS foam. We'll kick it off when we start. It's Kelly Weisinger from EDF, who is a co-chair of our lab-based landfill diversion working group. We'll be kicking off that talk about the EPS bulletin. So I'm just going to go over a few of the ground rules ahead of time. We do have everyone muted right now as you joined. I don't know if we turned your cameras off or not, but you can go ahead and turn those off now. And if you can keep them muted until it's time to speak, and keep your videos off until we have open discussion at the end. We ask that you listen with an open mind, where the purpose of these forums is to, speak both frankly, but, and collaboratively about how to address some of these issues that we're having in labs with toxicity and waste, and focusing on solutions and the questions that we might have, or lessons learned from various activities that we've undertaken. In this case, we're going to focus on expanded polystyrene, alternatives, reduction, packaging reduction in general, any recycling or reuse we've been able to do. And then, we might hit on the cold storage part. We realize that there might be a whole nother forum on this, but if we need to, we can talk a little bit about, and our speakers will talk a little bit about cold storage. So as I mentioned, if you have very direct questions for the speakers that you'd like them to address before we get into our audience participation time, go ahead and put those in the chat. And our next slide is about the community of practice, which hopefully everyone who's on here knows about the community of practice. It's circulareconomy.i2sl.org. It's a group you can join, or just look at the website, but it's better if you join because you have access to more stuff. And our main focus is obviously on laboratories, but ways to reduce and divert waste, as well as do sustainable purchasing to eliminate the amount of waste and toxicity of products coming into labs in the first place. It's free. You can participate in a whole bunch of different ways. There's a whole page on how to participate, but we want it to be interactive. Pose questions, answer questions, and you can submit a blog, or look at what other people have written, or comment on other people's blogs. There's a library of resources of great, speakers we've had out there, and some of the abstracts and reports that are available. There's more stuff available to those who register, FYI. And then we're really encouraging people to do videos. We have something called Phil Talks. Those of you who remember Phil know he was great at uplifting good ideas, and that's what we want to do. Instead of TED Talks, we want to have Phil Talks. It stands for People Helping Improve Laboratories as well. So you can make a video for something going on like at a supplier company, for something going on in your lab. Maybe students are working on something. If you need a stipend, there's even a form to get a stipend to make a video. And then finally, we're really here just to help users and managers of labs collaborate and coordinate with their suppliers. So if you don't see a supplier that's on today's participant list that should watch this or get involved, shoot them or me an email. We will put this recording on the community of practice site, and we want to make sure people know what we're talking about and get involved in helping to make solutions together. So that's why we're going to keep doing these like webinars and forum type roundtables so that we can keep talking to each other. So that's the community of practice in a nutshell. Just to keep us a little organized in terms of what we cover in the community of practice, we made ourselves a little editorial calendar. If you're thinking about contributing a short blog or a video, here are some of the themes that we're going to cover throughout the year. Most of them are sort of waste reduction, toxic reduction, and procurement related, but some of the stuff we're going to include is some of the stuff going on at I2SL to reduce energy emissions and water. But we do have some very specific topics that we'll be covering that are outlined here, including our favorite hot topic of animal bedding, composting. You know, we have winners of the freezer challenge in August, but what were some of their challenges that they faced? You know, reuse, whether you're giving back to schools or finding other ways to reuse lab products, recycling. Like I said, we may cover ice packs when it gets cold in December. So here's some of our topics. And with that, I'm going to stop talking and turn it over to some of our great speakers. So we're going to start with Kelly Weisinger. She's with the Environmental Defense Fund, but she joined the I2SL community in 2012 when she was serving as Director of Sustainability at Emory University and Emory Healthcare in Atlanta. Her involvement expanded in 2016 when she co-founded I2SL's Lab Waste Landfill Diversion Working Group, and again in 2020 when she became a member of our board of directors. Kelly now works as the Director of Corporate Sustainability for the Environmental Defense Fund, which is a global nonprofit NGO, I think everyone knows, dedicated to addressing climate change through sound science, policy, and economic powerful partnerships, justice, and equality. So Kelly, take it away.
Thank you so much, Kathleen. It's a pleasure to be here. Y'all are my peeps. I love when we all get together like this, and what a great way to kick off the start of 2024. I hope everyone's having a great new year so far if you celebrate. So like Kathleen said, I'm just here to do a little bit of level setting. I don't think many of us need to, need an in-depth explanation of why expanded polystyrene or styrofoam is a challenge, but I'm going to talk about it anyway, because we published a technical bulletin in July of 2021. The QR code is here on this slide, so I encourage you to take a look at that bulletin in its entirety, because I'm only going to cover just really brief highlights today. So with that, I'll get started. So first, what is EPS and what are its drawbacks? I know I shouldn't really start with drawbacks, but we're going to talk about the benefits of EPS in just a second too. So EPS is expanded polystyrene. We also know it as styrofoam, which is a trademarked brand name for it. So throughout the technical bulletin and in my speech, I will use EPS, or expanded polystyrene. And it is a fossil fuel product that's made from crude oil, styrene. So it obviously has a climate impact just from its source. It also has a really long supply chain that creates greenhouse gas emissions, pollution, and waste. Most expanded polystyrene products are designed to be single use, if not all. I don't say all because I just don't know, but the way we know EPS, it's designed to be single use. And so that kind of single use waste, when it's disposed of, it creates a whole host of problems. One of the issues is litter. Another is that it's known to be toxic to wildlife, and it causes marine plastic pollution. In addition to the litter and environmental impacts, there are social justice concerns with the manufacturing production of expanded polystyrene at both the resource extraction phase and the manufacturing stages. And while it's being manufactured, workers are exposed to more than 50 different hazardous chemicals. So obviously there are lots of public health, environmental reasons to try to minimize the use of expanded polystyrene. However, it's really beneficial to our society and especially to research. It's very lightweight and sturdy, and so it's able to be shipped and handled fairly easily. It provides reliable insulation, which makes it the packaging choice for the life sciences industry, which ships globally, and some things arguably need to be maintained at a constant cold temperature. And it's cost effective. It's really inexpensive to extract and to manufacture. So uses range from cold storage and transport to shipping and holding lab consumables like these conical tubes that you see. And also I just had to put in some fun photos. Many of you might recognize the person in the bright pink shirt in this photo, but some universities, including the University of California, Davis, use foam coolers for bowling competitions and tower building competitions, just to raise awareness about the ubiquitousness of this product on college campuses, especially our high-tier research institutions. So this probably looks familiar to some of you, and a lot of the time styrofoam in our laboratories looks more like this. You can see on the right hand side, this is the University of Colorado Boulder, and they have a robust recycling program. But even with recycling program, look at how much space these coolers take up. I think that all of us who've worked in labs or are familiar with laboratories know that most labs do not have this kind of space in the lab for the collection of recyclable expanded polystyrene products. And so oftentimes products get stored outside, which you see on this left-hand picture from the University of California, Davis. And so while that's that's fine, but storing outside also limits the reusability of these products. So having them shoved and crunched and stored outside to get dirty degrades the product. And so it actually decreases our ability to use it responsibly and try to reuse it. So I2SL and the landfill waste diversion working group have been working on this for a number of years. We've been conducting surveys of our members and peers and partners. We've had lots of discussion about what to do about EPS and the challenges that we face. We've shared solutions that we've come up with as individual institutions, and we've shared barriers, and we've had numerous conversations also with suppliers and manufacturers. So I want to talk a little bit about a few of the things that we as working group members and probably all of us globally have tried. So we've tried reuse. We've tried reuse in the way in which we redistribute expanded polystyrene products within our own institution. So many of the institutions that receive EPS coolers or boxes or other, conical cube, holders, we also ship out samples. And so it seems logical that if we are receiving these types of items in our incoming shipments, that we could then turn around and use them for our outgoing shipments. I mean, I could see probably a number of hands if I asked you to raise them for who's tried this. Some have done this successfully and are continuing to do it. But it can be really challenging for staff who are dealing with time, space, and logistical constraints. The accumulation and the distribution points are separate oftentimes. So the unit that ships out samples is really far away from all the units that receive shipments, and they can be far away, especially on life science and research campuses. Take back programs are a different type of reuse, and that is a great example of extended producer responsibility, where the manufacturer or the shipper of the product will take the foam cooler back or the EPS item back and reuse it. That's a great option, but there are only a few companies that offer that kind of turnkey solution that doesn't involve the challenging internal operational logistics that I noted before, where storage, perhaps moving those items to somewhere else on the campus or the property to be stored before they get picked up. And even sometimes the picking up of the product can be challenging. So, and I just want to note that many of these tactics are being tried by our researchers. And these are people who are researching life-changing, life-saving, solutions to our global challenges. And so we want these researchers to be spending time doing their research as opposed to all the time and energy they have, coordinating how to recycle or reuse expanded polystyrene products. Donation programs are great. There can be safety, legal, and logistical complications with doing this, often requiring consultation with proper environmental health and safety or legal counsel before offering EPS from labs to others. This strategy has worked for some research institutions. It's usually on a smaller scale and often in addition to recycling and reduction streams. For example, some universities have followed the lead of the University of Wisconsin, who partners with a company that makes frames, picture frames, from reused EPS, and after it has been densified and extruded. So that's a great reuse strategy, again, usually smaller scale and logistical. We've tried recycling. We've tried recycling on site at some of our institutions. That requires a densifier. Those densifiers are often are very costly, and they require space, they require staff, and they often require constant use of the densifier because the volumes are so high coming off of out of these labs. So while that's a great solution, it's often on a smaller scale and used by companies or institutions that have more space and staff to be able to man this process consistently. We've also tried offsite recycling, and the thing about styrofoam is that the same qualities that make EPS, desirable, also make it quite difficult to recycle. So transporting this light and bulky material to recycling facilities costs more in labor and fuel than landfilling it because of the way that the pricing structures of landfills work. The low market value, there's a low market value for recycling because it's so inexpensive to make EPS. And the reality is that recycling facilities don't exist everywhere. This is a map from EPSindustry.org that shows where EPS recycling facilities exist just in the US and Canada, and where they don't. And you can see some significant gaps in geography. And if you zoom in a little bit closer, take, for example, Atlanta, where I'm based. This is the home of the Centers for Disease Control and multiple Tier 1 research institutions and healthcare facilities. and it only has a few facilities, and they only accept items that are dropped off by the consumer rather than partnering with waste haulers or recycling facilities to transport this more efficiently. So even offsite recycling is challenging for us to accomplish. So now that I've outlined some of the high level opportunities and barriers and challenges that we have with this product, I just want to close with this sort of call to action about what's next. So our laboratory landfill waste diversion working group is developing a call to action for suppliers and manufacturers to help their customers with this EPS problem. In fact, many institutions have bans on EPS in their supply chain, with the exception of laboratory supplies, but that indicates that they're looking at those to be next. And so there could come a time very soon when expanded polystyrene is not allowed on some of these research institution campuses. And so we really need some action now. And you can see that in our 2021 publication, the Technical Bulletin, we revealed our very own waste hierarchy that is particular to EPS in laboratories. So you can see the very first choice is source reduction, avoiding the use of cold transport. So we're putting this call to action out to partners who can help us find alternatives to EPS for the uses that we need them for in labs. These alternatives need to be easily compostable or recyclable, or durable and reusable. And then if we can't avoid the use or find alternatives in certain cases, and it has to be expanded polystyrene, then we really need robust recycling programs that have extended producer responsibility, so that these producers can actually help build a robust both supply and demand for recycled expanded polystyrene. And for these suppliers and manufacturers to facilitate that in terms of reuse or take back programs that they help the institutions operationally with. And then obviously the least desirable is non-recyclable, non-compostable, which arguably is what we're seeing now. What's exciting is that we have had some great conversations, and in this paper you can read about some of the ad hoc solutions that have companies have tried or developed, and we're encouraging and celebrating and pushing further progress from suppliers and manufacturers. And today you'll hear more in depth about EPS reduction initiatives from two partners. And then after that, we look forward to hearing your questions, concerns, feedback, challenges, and calls to action for discussion at the end. So thanks so much for your time, and let's get right to our partner presentations.
Great, let's. Thank you so much, Kelly. And thank you to you, Alyssa, and our HEOSC fellow, Michaela, who put together this EPS white paper or a technical bulletin in the first place. Please do give it a look. I put a link in the chat. We will update it if we get more information. But now we'd like to hear from a couple of suppliers who have sort of taken that first step in the hierarchy and looked at ways to avoid having to use cooler storage for shipment and use ambient instead, as well as finding some alternatives out there. So our first, Kelly, I think you might need to stop sharing.
I'm trying.
Oh, okay. I'll go ahead and introduce our first speaker, who is Anthony Michetti from Cell Signaling Technology. And please forgive me, I forgot to mention at the very beginning that the community practice is made possible with a 1% for the Planet grant that Cell Signaling Technology provides I2SL as part of the 1% for the Planet program, where companies can give a percentage of their profits to great environmental causes like ours. And that's not even why we asked Anthony to speak. It's because they've also done some really cool stuff with EPS alternative shipping. So Anthony is a sustainable leader in our community with more than 15 years of experience spread across engineering firms, consulting firms, and academia. He's the director of sustainability now at Cell Signaling Technology, and CST is a private family-owned life science company founded and run by active research scientists. He also focuses on sustainable practice, and he did so in the lab during this time as the sustainability manager at Harvard University. And now his work is driven by creating the greatest impact to combat climate change and improve planetary health. So Anthony, I don't know if you're, there you are. Okay.
Perfect. Thanks, Kathleen. Let me get my slides going. Excited to be part of this and to help support this. I figured I'd start by talking a little bit about who CST is and why something like this topic is so important to us. We are a little unique in that we are a biotech company that is private and family owned. We're headquartered in Massachusetts. We are also in the Netherlands, in Japan, and China. Environmental and social responsibility is a big part of our core values and our mission. We are really an antibody company for research strictly. So we're working on developing antibodies to help cancer research, Alzheimer's research, and trying to get our customers the research tools that they need to do the work to advance personalized medicine and improve everyone's lives and extend everyone's lives without having a healthy planet to live those lives on. It doesn't seem as meaningful. So in addition to developing, the best antibodies out there, we're really focused on protecting the environment. We do a lot of work with our local communities across the globe. As Kathleen mentioned, we were the first life science member to join 1% for the Planet. What that means is we're giving 1% of our revenue, so not just profit, every year to environmentally driven nonprofits like I2SL, helping to advance sustainability in the life sciences is a big focus area for us. And we also do a lot to inspire the next generation of scientists. So, initiatives like getting rid of EPS and styrofoam and shipping is a great way for us to be able to talk and share best practices and engage with our customers on why something like that is so important and get feedback from them at the same time. So when we talk about looking at removing styrofoam or EPS from shipping our products globally, it's really being driven by our culture. So our scientists at the bench, we're shipping out, our product is getting shipped in a really small plastic vial if anyone on this call is working with our antibodies. But they get sent across the globe in our regions and through distributors. And really, everybody wanted to figure out, how can we move away from shipping in EPS? And whether that was looking for alternatives or figuring out how we can ship more and more product ambient room temperature. We also are obviously hearing a lot from customers. I've been on both sides, coming from academia before. Some of those pictures that Kelly showed, when I was at Harvard, we would have rooms full of styrofoam boxes and nobody would know what to do with them. When we were running behavior change campaigns or occupant engagement programs and initiatives, it would continuously go back to, okay, but what do I do with all these styrofoam boxes that I'm getting, and how do we work with procurement and supply chain and vendors to improve this and fix it? It's not an easy solution. We have been able to find more and more products that are out there to be able to make the shift and still meet what we're looking for as far as our operations. And I'll talk a little bit more about that on the next slide. Supply chain access is also a big part of that. And it's not just restricted to the US, but looking at a global scale, it can be difficult to get the same packaging that we're able to ship domestically with in Japan or in China or across EMEA. So we may find a solution that works in certain areas, but not be able to apply that, across our value chain, which can present problems. And as I mentioned, we have been able to move forward with a lot of ambient product shipping, which is really exciting. It's something that can be unique to the product that you're shipping and is not always possible for everyone out there. But I know that a lot of different people are looking at whether it's lyophilization or just a shift in SOPs and protocols and being able to ship a product, get it to customers within a day or two, and have it be at room temperature during that time. There's varying comfort levels, whether it's internally on leadership in our teams, or it's externally with customers in the different regions in receiving products at room temperature. How are we shifting away from EPS when we still are shipping product cold? We have settled on right now, and it's been several iterations, but we are working with the Temper Pack Climacell. Hopefully you all have seen this, even if you're not buying our products. We had been working with a similar type packaging before. The interior itself, the edges weren't sealed, and what's inside there is, a paper fiber, cornstarch fiber. We found that our product packaging team, when they were packaging things up with those edges not being sealed, there was a lot of dust being created. So we had found a good solution. It was allowing us to not ship in styrofoam, but some of the logistical things became difficult with our actual employees packaging it up, on an environmental health and safety perspective. And so we started to look at what other sort of solutions are out there. And right now we have settled on this product. It is fully recyclable. It's something we feel comfortable printing on there and explaining to our customers that regardless of where you are across the globe, this is really shipping more domestically though. There should be a street side recycling, whether you're at a university or at a private company. You should be able to recycle everything that is associated with this box. We have done a lot of testing to understand how it holds temperature and ensuring that it is keeping our product cold. And that is something that we continue to review and look at, and also sizing of packaging. So I think maybe once we have the discussion later on, we are very focused on EPS, but a bigger part of sustainable packaging, or not necessarily a bigger part, but another part, is the efficiency of which we are able to package up our products and the size of the actual materials that we are shipping in. We do ship in various boxes. We do ship to distributors who then get our products to clients. And it's all part of the consideration of, okay, what size is the right size when we think about greenhouse gas emissions associated with shipping, but also, what size is keeping a product cold for how long has been a big part of that conversation as well. Looking at some of our challenges and opportunities, which I'm sure are pretty consistent, and everyone has come across at least one or two of these. I already mentioned the global supply chain access. That has been really difficult for me. Even internal conversations for me, understanding, okay, being the head of our sustainability, I'm working to communicate, whether it's to a crowd like this or to a specific customer, or it's to our sales team, and feeling confident saying, okay, I know we're shipping in this product here. I know we're shipping in this product here, and I know we're shipping in this product here. It can be really difficult, and things can be fairly fluid and change, every few months. So it's a lot to stay on top of and understand, okay, we have this solution, the Temper Pack, in the United States. EMEA, our Netherlands regional office warehouse, does not have that same solution. We've been working to try to figure out a solution there. Japan, a whole nother conversation. We're, finally away from EPS there and shifting over. China, we still have lots of up and down and back and forth. And I'll talk to them and we'll have conversations, and it will be, yeah, we're shipping an EPS, but it's reusable EPS. And we know that it's not getting reused. And we've talked about take back programs, not necessarily tied to EPS, but other things. And it's just not the end all solution. So we continue to work on that. And that is, a cross-functional conversation that never stops until we feel confident that we've rolled out a solution globally, and we know when a product's getting to our customer, they are receiving it in a product that is recyclable and not EPS. Working with distributors, we're able to control a lot when we're shipping direct to customers. Distributors add that other level of uncertainty as far as I'm concerned, and it can be really important to have those conversations with them, understand what they're doing. We manufacture all of our products in the United States, and then we ship them to the regions, which are really warehouses where they then get shipped to distributors. We've done a good job of shipping from the US in packaging materials that can be reused for customer or distributor shipments across the globe. But the packaging that we send from here to those warehouses is never enough to cover all of the individual shipments that have to happen. So we know that our products are getting repackaged in a variety of different packaging materials from what we shipped out in the United States. I mentioned that we've done a lot to understand how long our product is staying cold in these various solutions. To me, this is something where I think of it is becoming more of a climate risk. If something is stuck sitting on a truck somewhere or sitting at a loading dock somewhere, in Texas or India, worried about, how quickly is the temperature in that box going to drop if it's sitting there for a long time. And, by the time it gets into our customer's hand, if it is something that has to be cold, and this is viability for them to use for their research. Sizing, I touched upon a little bit as well. This also factors into how long something stays cold. Our ability to fit a certain number of cold packs or dry ice in there, and the amount of product inside and how efficient that is, and looking at the ranges of, okay, this may keep something cold for this time period, and if we look at something larger or smaller and how we're packing it, it may extend that or it may shorten it. And obviously we're all here to talk about all of this, so it is very much becoming a customer expectation. I know when I'm working with our scientists at CST at the bench, we still receive a lot of shipments from our vendors in styrofoam. So I'm working on both ends, figuring out how to deal with that when it's on site for us, how to have those conversations in our supply chain with our vendors, and then obviously pushing it forward to somebody like Millipore Sigma or, the larger bigger biopharma that we interact with, the AstraZeneca's out there, and then, doubling down on their ability to push it down on their supply chain that we're part of as well. Some of the opportunities that are out there, before I pass it over to Dustin, just thinking about efficiency as a whole. So whether it's cold shipping or ambient shipping, we're doing a lot to understand, okay, what are all of our different product types and what are the sizes and weights that are actually associated, and how are we shipping them all when they end up in our warehouses? How are they getting to customers, and what does that time frame look like, and how does that factor into the ways that they can be shipped and the way that they can be packaged? Take back programs, we all know that there are plenty out there. I personally have never had a great experience with one of them, or feel like the environmental footprint associated with them is, in the end, better than sending something to incineration or waste to energy. We have lots of conversation with customers about the ability to help them develop take back programs and ways that our packaging can facilitate some of that, or just the ways that customers interact with our packaging. It's been a conversation for us when we think about revising some of this, or also, rebranding. The marketing brand team comes into play here as well. We think about what packaging is our customer actually interacting with. Sometimes, if you are shipping in styrofoam, maybe it's only making to the loading dock and it's getting unpacked there. By the time it gets to the scientist, it's in a much smaller cardboard box, or it's already put in their freezer or fridge for them. So thinking about bigger picture and how everyone's interacting with each piece of the packaging is certainly an important part of this as well. continue to look for new materials as they get developed. And I know we're not really addressing this today, but cold packs are, even if we've moved away from EPS, we're still having to use dry ice, so we're still having to use cold packs. And the best solution right now is, non-hazardous liquid inside that perhaps can be thawed and poured down the drain, but we're still looking at, a film plastic outer that customers have to figure out how to get rid of. So definitely lots of room for progress, and it's great to see everybody continues to work on this and continues to look at new materials and products that are out there. And that's everything I have, Kathleen, so I'll pass it over to Dustin.
Awesome. Thank you so much, Anthony. And thank you both for this presentation and for continuing to work on this topic, because it sounds like, your job isn't quite done yet, but we appreciate your continuing to address these challenges. Next up, we're going to hear from another supplier, Dustin, who's been with the life science company Millipore Sigma for more than 5 years. He started as a packaging engineer in Milwaukee, testing, qualifying, and improving packaging for shipping dangerous goods. And he's now in Millipore Sigma's Sustainability and Social Business Innovation team, overseeing North American sustainable packaging strategy and improvement. Dustin began working on EPS cooler improvement in his packaging engineering role and brought it to his new role to ensure the project's success. He also oversees packaging improvement policies, tracking and guiding teams toward progressive sustainable improvement at Millipore Sigma. So Dustin, take it away.
Yeah, thanks, Kathleen.
Sure. And while you're doing that, I'll just remind people, I have some panel questions, but I think I'm going to go ahead and open up the discussion with everyone afterwards. So if you have some questions you want to start with, go ahead and throw them in the chat both. Okay, thanks.
Okay. As you can probably tell, my background is pretty technical. I started as a packaging engineer, and I've been leading this project for Millipore Sigma's Greener Cooler project for the last couple of years. So in this presentation today, I want to share with you some kind of like a hybrid approach of like what we're doing, along with ways that you can kind of take ways that what you can do to find success in replacing EPS where you may be, the environment you may be in, or at least just to know some of the challenges and what we're going through to try and replace EPS as a large distributor. So yeah, if you're unfamiliar, Millipore Sigma is a huge life science company. We supply life science materials, anything from non-haz to dangerous goods to all sorts of different materials. We have a product portfolio of over 300,000. So we have a large amount of various sizes and products that we ship out. And I'm a packaging sustainability specialist, so I'm glad to talk with you guys today. So today I wanted to cover how we're going to eliminate EPS, the current technology, how to find success if you're sourcing a greener alternative yourself. And then lastly, a really important topic is it actually more sustainable to change to one of these coolers? Because we've done a bunch of testing and we've done some LCA, some life cycle analysis to see what is the impact of changing to a greener cooler. So first, as already touched on earlier today, I wanted to re-highlight, as there is actual benefits to EPS coolers that make the swap a little bit more difficult to navigate. So first, let's go over some impacts of the EPS coolers. The main benefits to EPS coolers is that it's so lightweight and it's really good at what it does. It provides really good thermal retention. And then also it is very cost effective. As stated before, there are many suppliers out there that offer this solution for cold chain shipping, and typically it's pretty local and at low cost. However, there are many negative impacts. For example, poor production impacts, like stated before, the materials used and the energy necessary to produce these EPS coolers. Also, a huge factor is that you're shipping a lot of air whenever you're even just receiving EPS coolers, because these coolers are preformed, meaning they can't be shipped flat or assembled on site. These are preformed in their like bin structure, and so you're shipping a lot of air just to even get these coolers to the place where you're going to be packaging your materials. Additionally, these are a single-use waste product. Also, disposal or reuse is very difficult. And then local laws banning EPS, company policies requiring alternatives. Recycling centers gain very little from collecting and recycling these EPS coolers just by the nature of the material. So how is Millipore Sigma targeting EPS? Well, we actually have a this is called our Smash Packaging program. It's our holistic approach to all things packaging sustainability. I'm not going to get into the details here, but this is kind of an overview of our 2022 status. Originally, it was only our 4-year plan to improve packaging sustainability. However, in 2022, it was supposed to be done, but we revamped it and we're pushing out Smash Packaging 2.0 that takes learnings from this program and expands upon them. And what's important for you to know is we have key points in here, as circled here, that indicate how we're targeting new product packaging aligned with our sustainability standards for recyclability. So we're improving that circular economy. And then also directly specific to EPS, we're targeting the decline use of EPS or the reduction in EPS. And already in 2022, we've reduced our EPS usage by 23%. This is through coolers. This is also through padding, things like that. But coolers are a huge factor in terms of how much EPS we use. So it's a large topic for us. So as shown before, we actually use the exact same kind of strategy to reducing our EPS cooler usage. The I2SL's article, the expanded polystyrene use in laboratories article, shows this diagram that perfectly outlines exactly our strategy as to reducing EPS usage or EPS coolers specifically. The first and the best possible way you can reduce EPS coolers is the full elimination of the cooler system. And without the necessary need or without the need of the cooler itself, you're reducing your impact as minimal as possible. And how you do this is through 2 different ways. Either the first way, you have to engineer products to be shipped ambient, meaning this could take time and resources to be able to modify or change the product to be able to not degrade over ambient shipping. This would avoid, of course, the cooler and extra packaging as a whole. Alternatively, you could qualify products for shipping ambient via testing, find product portfolios that wouldn't be diminished with shipping in these warmer temperatures for a set amount of time, and so on. So that would be the best thing to do, but it is very time intensive. Additionally, the next tier on this pyramid is alternative coolers. So alternative cooler materials is where we're focusing right now the most effort, and where I've been focusing my main project. And so this is really where ambient shipping isn't possible. The first thing in this category is easily compostable or recyclable alternatives. And this is the kind of coverall for general customer shipping. And the other category that is possible is durable, reusable alternatives. And these offer the most superior thermal retention, even over EPS, because usually they use robust materials that really encapsulate the shipping environment. And then, but however, they also are usually high upfront costs and energy to produce these systems. And it takes a very precise system to be able to collect the durable, reusable material back and then reuse it and ship it out to these specific customers. And lastly, greener EPS usage via recycling awareness or a take back program. We've actually had, as the others have said, this is very rare to have a company to have a take back program. We have had a take back program that was made very simple. All of our EPS coolers in the US get shipped out with a pre-printed shipping label on the box. So all the customer has to do is flip the top flaps opposite to how they received it, and then tape it back up and ship us back the cooler, and we will replace the outside box, but we will reuse the EPS cooler that gets just packaged into a new shipping box, so that again it can be returned and recycled or reused. However, we have seen a return rate of roughly 9% now, and it's really not viable, and it's not a really good solution in terms of trying to eliminate EPS usage or to try and improve here. So we're focusing on the easily compostable or recyclable alternative. And this is generally what people decide upon too, because it's the fastest and most effective in terms of wide range of shipping options. So what is some technologies in this area? I can talk about it theoretically, but here's the main solutions that exist right now. On the left side, you see the paper-based technologies that we've investigated. So you have a couple here that are like recycled fiber cooler. This is generally adhered recycled material. Typically, we found these are pre-consumer, post-production recycled materials that are just recollected and made into a cooler-like structure. Also 100% paper. Another solution that exists is a paper-lined cooler. So this is layered paper, typically also recyclable, but entirely paper-based materials. Another technology in this category is starch-based cooler. This uses a blend of starch mixed with cellulose to kind of make these like foam-like material that is still recyclable, but this area does pose some questions as to if the recycling centers do receive abnormally high amounts of these coolers in the future. Is it really still, is there enough collection there from these materials? So there is some questions there, but that's why I say it's important to have it certified recyclable, that the supplier goes through the investigation that it is recyclable and does not negatively impact the recycling centers. And then on the right side, you have some other materials that are, they still provide benefits over EPS. So for example, waste avoidance solution, coolers made out of material that would also be just normal waste products. It's not, these coolers aren't producing new materials for just the cooler single-use product. We also have plastic coolers that use recycled plastic, generally PET. And this offers like cushioning and also the use of plastic. So there's more applications to use recycled plastic. And then lastly, biostyrofoam coolers. These are usually used in scenarios where you still need a lot of thermal retention, but you're trying to still make a benefiting factor where these won't be taking up too much space in the landfill. And they use good materials too. So how to achieve replacement? This is something that we've learned a lot and came a lot, or like advanced a lot in this topic so I would like to share it with you. First and foremost, obviously, is around acceptance criteria and know what you need. So product storage temperature does not always mean failure temperature. You need to know your products. You need to know what temperature the product actually starts to degrade at. So you need to know more about what you need for individual products and where they're safe at. Also set accurate times. So research your distribution channels, know how long it actually takes to get to your customer. You don't want to have just, as long as possible to qualify according to EPS, because EPS is generally better than, or it holds temperatures better than greener alternatives. Second, consider cooler system modifications. There are so many different impacts that influence how long you're able to hold temperatures. And with that, all of these things impact as to how long you're going to last and how long the product is going to maintain temperatures. And some of these factors include the size of the coolers, the product placement, the insulation thickness and density, the shipping specifications, the coolant type. This is mainly a factor when you're talking about dry ice, like dry ice pellets versus bricks. that impacts the performance a lot. And then entrapment of internal climate, like utilizing inner constructions like boxes or you don't want to use films, but internal boxes to kind of maintain more entrapment of the air. And the third step is becoming experts in your own cooler. So with all these different variables and all these different modifications that you can have to the cooler, you need to know your cooler specifically. So the first thing is general supplier testing does not always indicate how your cooler will perform. It's a good indicator as to how good their product is, but in the end, you need to test your own cooler and test your own sizes and all the other modifications. Also, modify and test all the variables so that you meet all your needs. And then lastly, different coolers for different needs. So potentially you wouldn't want different coolers for different seasons, but potentially different ice amounts for the seasons, different coolers for the different climates that you're shipping in or out of or to, and then the distance. Are you shipping internationally or are you shipping locally? These are all areas that we've found success in, and we've learned a lot in terms of trying to find a solution. So lastly, and I think this is a really important note, is it actually better to change? And we've done a couple life cycle assessments on this, and this is of course guiding us is our change actually better besides just eliminating EPS? We know EPS is not the solution, but is it actually greener? So exploring the impact via life cycle analysis, is a fiber cooler more sustainable than an EPS? Yes, it is, but not in all cases. The major differences that come down to the life cycle analysis between the two is that EPS has a lot higher production for the production impact and the end of life because it gets transported and ends up in a landfill, whereas the greener cooler has higher supplier transport impact and higher distribution impact, meaning like getting the products to where you need to be. There's not as many EPS suppliers around areas that you may need them. So transporting them potentially farther distances to get them to where you needed them. And then of course, higher distribution impact is what I'll get into next. So it all comes down to cooler weight. Alternative coolers are typically denser / heavier than EPS, which is a major factor because transportation is typically by air for cold chain to be able to get it to the customer next day by air, right? You need to get your products to the customer as soon as possible to limit your time that you're actually having a passive cooling system. So weight, when you're transporting something in an airplane, weight is a huge factor in terms of the emissions that are generated. And this can actually balance out all other drawbacks for EPS, and which also means if your system is worse at thermal retention than EPS, you may need to add more ice, which means more weight as well. So balancing weight with the rest of the impacts of the cooler is a huge factor in terms of trying to find a positive impact, a positive change to swapping compared to what you're currently using today, which is EPS. Lastly, I needed to state this here too. Additional considerations that aren't really quantified in an LCA, so things that you can't put like kilograms of CO2 emissions to, is the avoided landfill space. Having something break down in a landfill it's not really capturable by like a CO2 emission, but it is definitely a promoting factor in terms of a system that is better than an EPS cooler that takes years and 50+ years to break down in a landfill, as opposed to potentially something that takes only weeks or a couple months. And then lastly, storage space too. Storage space of the EPS coolers is a massive area that is not really quantified, but it takes a lot of space to store EPS coolers because they're preformed and they can't be broken down or assembled on site. And that's all I had for today. Thank you.
Awesome. Thank you so much, Dustin, for both giving us like what lessons you've learned and geeking out a little bit on packaging materials for those of us who geek out on recycling. That was fun. We are at our time. However, our speakers have agreed to stay on for people who would like to ask some specific questions or get involved in a discussion about EPS. So we're going to keep the recording rolling here. And if people want to open up their video cameras and either, ask a question or share an experience of your own with EPS. We have some good questions in the chat. I think a couple of them got answered. But Kelly, did you want to revisit your first one that had to do with whether the internal goals had been, discussions have been set, or do you think that got answered at least by Dustin?
Yeah, I think it got answered in Dustin's presentation. I was just curious how, formal most suppliers, how formal those conversations are about EPS. Is it sort of, oftentimes with sustainability, it's like whoever's most vocal at that moment in time gets the airspace, and then we move on to a different issue if that person leaves. So it sounds like Millipore Sigma has established goals for reducing EPS. And I'm just curious if you guys think that's commonplace or really uncommon in your industry.
From what I can speak to is I believe Millipore Sigma is pretty ahead of the game here in terms of like having a specific smash packaging program to eliminate or reduce a lot of our, I guess, inefficiencies in terms of packaging as a whole, but also making it a clear point to outline EPS reduction and here's how we're going to do it and X, Y, and Z, how these things are going to work, all the different areas of EPS. So I think this is something that could be expanded upon further with other companies. And I think this is the best time to do so because there are so many new technologies coming up with alternatives to EPS. But from what I've seen is, yeah, in terms of strategy and improvement policies, I think Millipore Sigma has a lot to share here, and we're definitely ahead.
Okay. And people feel free to raise your hand and unmute your mic if you want to speak. Again, share your own experiences. We had a few different questions about LCAs. I know we touched on the LCA that you all did. It was that was basically EPS, but we also had a question about LCA comparing EPS take-back programs to recycling and landfilling. Was that part of yours, Dustin? Anthony, I don't think you had one, so.
I didn't detail this too much, but in our LCA comparison, we did consider our take back program and the rate at which we do receive it. And essentially you're avoiding the production of another EPS cooler whenever you do have a successful return program. So it is really beneficial to, not avoid the major negative impact of an EPS cooler by reusing it. However, the participation in the program is very low. So it's the consideration of only 9 to 10% is a factor, but still, yeah, it's important to weigh like the benefits of offering the program and then also the utilization of it.
Sure. Star.
Hey everyone, thanks for a great presentation today. I'm Star Scott, University of Georgia. Dustin, I wanted to know, is that LCA something you could share with us that we could look at that? And I also had a question too. You mentioned a 50-year breakdown on expanded polystyrene. The research I've seen is closer to 500 years. So I'm curious like where that came from and if it's a specific type or maybe a specific density.
Yeah, I may have misspoke on the 50-year 50-year claim of the breakdown of EPS. So I apologize for that. And unfortunately, no, the LCA cannot be shared. It's not published quite yet, so we can't externally share any data specifically from that, especially since we are still defining like what our our solution is to our EPS replacement, but we will definitely be publishing a peer-reviewed LCA once we have this solution locked down.
Okay,
Awesome. Thank you so much. I think those are going to be so important, not just for the EPS story, but for all of our lab consumables and equipment. We really need those LCAs to help guide us through this. So thank you for that.
yeah, fair enough. And we'll share whatever we can on our circular economy site. And just folks, Kelly put a reminder in the chat if you need to jump off. These are conversations and questions we can pose on the community practice website as well, and people can jump in and comment. So please do continue the conversation there if you have to jump. We did have a question about from Dave Jones about the life science companies represented here seem to be at opposite ends of the production scale. Is there collaboration among multiple companies to address these problems together, or is it considered like a proprietary R&D issue that you don't really work together?
I can start with that. I would love to say that there is more, but similar to Star's request for the LCA, you know, and why we're all here today, the best practice sharing, knowledge sharing, there certainly could be more of that. And all of the initiatives that we've taken to remove EPS and really across the board for sustainable packaging, I think we look to learn from others and we say, oh, you know, we got this, or we've seen this, or a customer shared this, but I have yet, you know, to work directly with another peer or competitor on an initiative like this. My hope is that as solutions become more widely available, and, you know, others like Millipore Sigma, the work that Dustin is doing is way beyond any of the work that I have the capability to do, you know, at a CSD level. So I would look to somebody like them to say, you know, we did all this work, here's the solution that we recommend. And then, you know, I see that as my goal to really take that and then implement this and, you know, talk to leadership about why it makes sense to do that and see it more on that front, but always more room for collaboration, definitely.
Great, thank you. I think we've captured most of our questions, but if anyone has one that you wanted to make sure we asked, let me know. And when you've looked at talking about LCAs and whatnot, did you kind of go through that in each of your alternatives, like and looking at things like the real recyclability, like it's recyclable by definition, but collectible. Did you all kind of do that sort of analysis, or is it sort of like, you know, we're going to offer an alternative and see if the market can, what they can do with it?
For our LCA, we used typical research into, or like typical metrics into recycling potential right now. So our solution that we're investigating is curbside paper recyclable. So we used existing metrics on that as to kind of assume or gauge the likelihood of the program that we're trying to replace EPS with.
Yeah, and I would say it's a similar fashion. Obviously, it changes within the United States from city to city and globally from region to region. So it can be difficult to, you know, put a uniform blanket, yes, this is recyclable, and just tell customers that. We've run into a similar, you know, prior to where we're at now with the temper pack and then the paper base that Dustin was describing. We had a fiber base, but it was, you know, enclosed in a biodegradable film. And to tell customers, you know, this is biodegradable, but, you know, where do they put that? You know, to me, it's like, okay, we can have the solution and we can say, you know, it's biodegradable, recyclable, but if the customer can't interact with it in a way where it's getting to where it needs to be, then it's not really a good solution. So I try to rely more on getting direct feedback from customers and engaging with our sales team and, you know, marketing and those people who are getting that type of feedback. But there can definitely be disconnects there for sure.
Great. Did you want to share something, David?
I was just going to say that issue of biodegradability is one that we've wrestled with at Penn State University, specifically with regard to gloves that are marketed as biodegradable, but we don't have a system that can handle it on campus. And so it's it's either larger scale academic institutions or organizations that have to be able to implement a larger scale system, or just the collective system together has to be built. So you can market something as biodegradable in theory, but if you can't carry it out in practice,
Yeah,
Yeah.
I think I just wanted to speak on that too, is like, that's another finding, as well as the whole terminology behind what is like more sustainable, biodegradable being one of them. Okay, is it biodegradable in what kind of environment? And is the environment widely accepted or widely achievable by the public or the scenarios that you're shipping to, right? Is it biodegradable in a landfill, or is it biodegradable in a very specific compostable kind of environment? That's something that we also found is it's a challenge, because these terms are thrown around a lot.
Yeah, I
Yeah.
agree. I'm just thinking about the weight issue, and how I can see both sides, like, for institutions that don't have a industrial composting system that they either have on site or have contracted or partnered with locally, that's permitted locally. That is a challenge, as David brings up, and having a compostable product could offset the weight issue, where transporting EPS to go get recycled is inefficient. But since some institutions are already transporting heavy food waste to get composted, that heavier product, if it's compostable, won't quite make as big of a difference, in terms of carbon emissions, if we're already sending heavy food waste. So that would be a really interesting comparison. And I've seen, other alternatives like mycorrhizae, and I appreciated your slide, Dustin, that had like denim and like, reused fibers and things like that, which are so great to see, but it does challenge the customer just the same with the disposal of that waste, diverting it from a landfill, just like the EPS does. So
Yep, always trade-offs.
yeah.
Alexander, did you have something you wanted to share?
I just wanted to say thanks also for the presentations and all the feedback. There's a lot of really great information in this webinar. I had to come in late, so I'm hoping I can check out the recording. But while I've got you, I was wondering if anybody here had any experience with, so we've got a vendor who is like touting a circularity model for their lab consumables, in particular their polypropylene products, their plastic, but they also offered to us, not necessarily a circular model, but they offered to us they would take expanded polystyrene off our hands, and they basically have a process where they, turn it down into an ingot, and they don't turn it back into like, the foam coolers or whatnot, but they turn it into things like playground equipment and, I guess limited scope of what they can actually do with it. And I was wondering if anybody here has experience with, sending things to an EPS, recycler, and whether or not, how much we like believe in that as a group here.
Yeah. Any comments from anybody in the group who's participated in or been wondering about that?
I'll respond to that. I'll jump
Thanks.
in here. Alexander, why don't you come join our landfill diversion working group meeting next month? We talk extensively about this. We've had a lot of us have had a lot of involvement for many years with this, and we'd love to share that knowledge with you, and just kind of share where we're at. I think different institutions are at different places with that. It really depends on if it's getting downcycled, what is it becoming, what's the use of that product, also the shipping involved. There's a lot of components to that, but we'd love to have you join our group. We share a lot of information readily, and also check out the community of practice too, because that's where we share a lot of this information. So yeah, we'd love to have you join us on that.
Thank you so much, Star. I appreciate that.
Great. Yeah, we can put information, or Kelly, I don't know if you want to put your info in the chat, or you can even email info@i2sl.org. We'll make sure you get invited. And anyone else who's interested in the working group. Always lots of topics.
Thank you.
I think we've covered all the sort of questions and discussion about EPS. I think there's probably more to come. Like I said, we can revisit our paper. We could probably spend an entire time talking about ice packs. So maybe we will do that later in the year. But thank you again to our speakers who put a lot of effort into both addressing this issue and kind of boiling it down for us and answering our tough questions. And to everybody who participated with questions and is still trying to tackle this issue in your facilities as well. So thanks everybody for our first forum, and we look forward to seeing you at the next one and virtually in the community practice.
Thanks, everyone.
Thank you.
Thanks all.